Well, I used to be a surveyor making maps and spend a lot of time in Africa, South Arabia and Central America. And particularly in Africa, years, if you like, walking through miles and miles of burnt Africa. Ghana was one place, and the lowlands in Ethiopia on the border with Sudan was another. And particularly in Ghana, in the dry season, virtually the whole of northern Ghana goes up in flames. It's grass, and it should be savanna woodland, and the bits that are being preserved are savanna woodland, but this is now just grass, and it's either hunting fires or it's agriculture got out of control, an agricultural fire, slash and burn, that's just swept through bone-dry countryside. And it has a devastating effect, and I've always loved nature. It's where I feel at home, since I was, my earliest memories are to do with nature. I brought up in Gloucestershire and then moved here when I was 14. And I think it was, that affected me very much. I was always actually more interested in the places I was working in than I was really in the outcome of the work. I was a good professional and I took a lot of trouble, and it was very satisfying to do some of those things. But what was getting to me was what I was seeing in these places. I saw in Central America working, I was doing hydrography on one of the big rivers there, and I was watching people burning up on the mountainsides and seeing the fire, and then a couple of thousand feet above it, clouds forming above the rising air, and thinking, oh, this is actually devastating, and seeing the entire landscape stripped of rainforest, had been covered in rainforest, and it's no longer. And just asking the child's question, why? The way of, you know, if I could put myself back with a man's mind and a child's heart, I'd be looking at this saying, why? And I was also, I'd always, at this time, was reading a lot in the field of ecology, organic forms of agriculture, that kind of thing. And I just started chewing it over. And I got to a point in my life where I was freelance surveyor, but I was on contracts to big consulting engineers mainly. And that was all going to change. And I was sort of coming up for what I think for most people would be a midlife crisis. And before it became a crisis, I kind of preempted it. And I decided I wanted to go back to school and learn more about environmental stuff than what I was doing already. And just cut a long story short, ended up doing a master's at Cambridge under Tim Bayliss-Smith. And he's a geographer with a strong ecology leaning. He specialises in, well, Western Pacific, but he lectured in rainforest ecology. And I went with the intention of just learning more about the ecology of slash and burns. I had a year of classes in Cambridge, soil ecology, geography of Middle America, development studies, tropical ecology. I spent a lot of time in the botany department and the applied biology department, and began developing then reading around the subject of slash and burn. And during the second year, concentrated on the ecology of slash and burn, what was going on, what was known about the effects of what's happening in the soil, why it is that you have, there's this fundamental question, an extremely productive ecosystem, the most productive on the planet. The rainforest is producing annually in the region of 25 to 30 tons dry weight per hectare per year. And that's pretty well the top productivity. I mean, there are agricultural systems that can be driven to do more, but as a natural ecosystem, that's extremely productive. And yet, maybe 1 or 2 years after it's been cut and burned, you're struggling to produce half a ton of maize and the same quantity of plant trash. But the weeds do well. But you know, these are fundamental questions, the sort of question a 10-year-old could ask, and the answers weren't there in the literature. There was indecision, there was clarity about some things, but there was no real punch. There was no explanatory power in what I was reading. And in a couple of points, there was actually contradiction. And that needed disentangling. And I went to Costa Rica and did some field work on what you'd call the agricultural frontier, where people were literally chewing into secondary rainforest that had already been logged in a corrupt system and is no longer of any value to those corrupt officials who'd caused it to be logged, so they're not going to defend it, so nobody gets shot for going into primary rainforest. And these guys were given concessions and they were slashing and burning. And I was able to take a whole lot of samples of soil from the forest itself, untouched, and people slash and burn sites. And I also went back to a site that had been a study done by an American professor, and I resampled the soil from the forest that he left intact, and then from one of the plots that he'd burned. And went back to Cambridge, started doing, I'd already focused on the nutrient ecology, and I was looking very concentratedly at phosphorus, which kept coming up as one of the key possibilities. The availability of phosphorus to the crops is a key nutrient. When you put it on fertilizer here, it's NPK, and the P is phosphorus. And there were strong indicators from what we know about the functioning of intact forest that phosphorus could be one of the keys, but the literature didn't give it. The literature just didn't get a grip on it. And I began doing analyses, fractionation of soil phosphorus, soil microbial phosphorus, all sorts of rather ambitious stuff, and finding that the checks I was building in just were not adding up. And then questioning the methodology, and then spending a lot of time with a couple of dear old professors of chemistry and asking about what on earth is going on. Why am I seeing these big errors, lack of precision in what is a very uniform material? And they didn't give me the answers, but they gave me some pointers into old laboratory literature. And when I began to go back again, redo all the samples, think about it some more, follow some of the old guidelines, suddenly I discovered that a lot of the standard methodology for finding out how much phosphorus is in that plant or in that soil or a given material is actually subject to a lot of error. Once I cracked that, I went back to the soil samples, and I then began to see very consistent answers coming back. How much phosphorus is in this soil that hasn't been touched? It's intact forest. This is a plot that has been. It was actually 7 years after the guy did the burn, and I sampled that. It hadn't been eroded or anything, and there was a massive difference. And I went back to his literature, and he's completely blundered. He's totally and utterly wrong in his numbers. He's put a number that's 3 orders of magnitude wrong. He's published that. It's just an error. It's not bad science. It's simply, it's a blunder. What in error science you'd call a blunder. Errors in science are the little variations that occur in all observations. That's normal. And surveyors know how to deal with them. And this was not. This was something massive. The point was, it was the key nutrient. I discovered that there was a huge loss of phosphorus as a result of exposure of that soil. And it's phosphorus that's the key. Now, when I wrote this all up as a thesis, and when I was finally able to get some funding, went back to Costa Rica, we got collaborating institutions, and we burned 2 hectares of secondary rainforest in the lowlands. So you're talking to an environmental vandal. And we studied the effects pre and post burn, and then we were able to put cropping systems in place and monitor them. Every component of those ecosystems that we put in place, we measured. So we grew maize immediately after the burn. I had plots of what's called conventional alley cropping, which I can tell you now failed within about 3 years. But we also had bare soil plots, which within 6 months were infested by grass. We monitored and measured everything above and below ground, and in the end got 7 years data. And the one system that came through 7 years with any indicator of sustainability was alley cropping, which you've seen in the film, but using Inga. Now I'm sure there are other plant genera that will do the same, but I haven't found one. But Inga was a powerful restorer of soil and what would you say, a conserving influence on the soil. And 7 years after we carried out the burn, that system was still functioning, still producing grain. Well, the story from then was I managed to get some more projects funded. In the end, we had 4 through the geography department in Cambridge, of which the last 2 were really go out and do it. We don't want to fund you with any more science, but you go and prove it. And we then put in trials, demonstration plots and trials with farmers, as you've actually seen. And due to one of the demonstration plots, the character in the film, Faustina Reyes, who's now working with us, he was introduced to the system and immediately saw what he'd been looking for. And the rest of the story is told really in the film. Yes and no. Farmers will naturally be very conservative, and you said yes, of course, and they're much better at assessing risk than they're often given credit for. But I don't see a problem there. Our bottleneck is funding, and the task and the difficulty that I've been facing up to now has been, we know we've got a promising system, we know it works, we can possibly satisfy the demand from farmers that we're seeing. And the strategy we've adopted now in Inga Foundation, all the people involved with me, by the way, in the previous projects, Tim Baylor-Smith being one of them, but also Terry Pennington, they're trustees of Inga Foundation. So we're the same usual suspects, but we're now called something else. And our problem, I think, is to make sure that we concentrate in a convincing way in one area, not to spread ourselves thinly to farmers in general. I mean, I know if I went into the next valley, I know what the answer would be. Yeah, we want you to come and work here. Well, we can't, because we haven't got the resources. So we're concentrating in, it's actually 2 river catchments. One called the Rio Cuero, and the other is at a place called Capapan, which is being managed by Mopavi, who's another character in the film. And our strategy then is to establish not just the alley cropping for food security, but a whole model of a rural livelihood with maybe 200 families at such a level that nobody could fail to be convinced this works. And then to use that, well, not only because it's where we're working is worthwhile in itself, but there's a big conservation dimension to it as well. And thirdly, it's going to be a model for the whole region. I'm not going to be able to put scattered examples of alley cropping across the entire landscape and then say, we've started a viral process. It won't work like that, because you must demonstrate convincingly. And I think that the key factors there are going to be, of course, food security. That's number 1. But secondly, using the system for generating cash crops. And we mentioned this in the film. I mean, I didn't have any editorial control in the film. I didn't want it. It's Adam Wakeling's film. But you see there the thing we're calling the Guama model, which is Guama's name for Inga in Honduras. And you have there, for example, on average, we're told a family will have access to about 8 hectares of land, all of which now is probably degraded into grassland, just like the landscape you see those guys trying to grow beans in and failing. And usually for subsistence they'll be cutting maybe 2 hectares, maybe a bit more every year for basic grain, just to live. And so what's happening is that all that 8 hectares is being sucked into a tight and degrading cycle of slash and burn that's just getting lower yields and more weeding effort every year, and eventually they'll just leave it. And you hear Faustina saying, well, we abandoned this, it was sterile, couldn't produce anything. Well, we're getting that answer from all of them. I mean, the difference between what we found in Costa Rica and that in Honduras was that when we slashed and burnt a site, it was it was secondary rainforest, at least 25 years old. And whatever fertility the forest will have built up over probably millennia was still there. And the question we then answered was, well, what happens to this inheritance of nutrients? What is the system doing with what it sees when it first gets planted? And my answer is, and it was confirmed, was around 3 years after the burn, we suddenly saw in the exposed soil enormous losses of the key nutrient, phosphorus. Now in Honduras, the trials that we were putting in place a dozen years ago were on sites that were already degraded by many cycles of slash and burn. And the guys were saying, this is sterile, I can't do anything with it, it's just grass. And even if I slash the grass, I won't get any crop. And what we found with the system there was it was actually pulling it back, but it was just taking longer to get a grip, to recapture the site and to render it productive than we'd seen in that very fresh site in Costa Rica. So there were two questions. Can this system regenerate the degraded soil? And the answer is yes, but very slowly. And yes, especially if you can put a bit of rock phosphate on to help the trees. That's counterintuitive to farmers. You know, you're going to put fertilizers on trees? We can't eat the trees. That's mad. So introduction of a system like this is going to be slow, and it's only done by demonstration. And that's the task. So the strategy, for better or worse, rightly or wrongly, that we've adopted is concentrate. Do not spread. Concentrate. Make it work. Well, I can now say to you that since the film came out, there's been a lot of interest, and among other things, people have donated through the website. And I no longer have to worry. I mean, I was with Faustino 2 months ago, and he said, we've got a whole lot of seed from one of the species of Inga coming up. In November, we expect to see a lot of it. It's the biggest crop I've seen in years. He said, you know, we really need to exploit this. And I said, great, take on whoever you want. 6 guys for a month, 8 guys. Get as much in as you possibly can, get the soil, get the nursery sorted. And we've done that. We're going to behave as though the answer is yes. That's an act of faith, but just as starting this is an act of faith. And the 10-year vision we have for the Quera Valley is this. Assuming that 8-hectare average of access that a family has to land, and it's all degraded and it's all like this, it's steep slopes. Yeah. Assuming that's the case, doesn't matter if it isn't exactly accurate, but just assume 8 hectares. We now find that out of the 8 hectares, all of which is today needed for, they can't sacrifice it, they've got to have that there to live. But 1 hectare is enough to feed the family in perpetuity. As far as we can see, you probably need to put some rock phosphate on to just top up what you're taking out in the crop, because an effective cropping system is also a form of export of nutrients. But with nitrogen, it doesn't matter because the air is full of nitrogen, and the trees are legumes and they fix the nitrogen, so it's not a problem. But phosphorus is absolutely critical. The world is going to run short very soon of phosphate. It's really important. I mean, you're looking at an estimated 250, 300 million families living by slash and burn. I have no idea whether it's true, but that's a lot. And they're firing anywhere between 1 and 2 billion tons of carbon into the air every year, and that's a hell of a lot. That's between 20 and 25% of all human inputs from slash and burn, and none of it for the energy that it's releasing. So they're not burning it as we're burning here to keep the place warm and cook. They're just burning it to create temporary fertility, and it really is temporary. And I've now got the data to show exactly what happens when you do slash and burn. Okay, that's a lot of people. That's going to be a massive logistic task. And what came out of these years of study was, in order to live on one piece of land, you have got to have access to at least small supplementary quantities of rock phosphate. But secondly, you must have in place a system that's capable of taking it in, retaining it, and recycling it. So you've got those two factors, not just the resource. You don't just add it in like spooning sugar into coffee. You must have in place also a system that will be parsimonious with that critical nutrient. Now, to exaggerate it a bit, a farmer growing grain here might, to get an acceptable crop of maize, for example, there would take out 5 kilograms of phosphorus per hectare. Okay, a farmer here could conceivably fire on 105 kilograms, waste 100 in order to get 5 into the crop. It doesn't matter, because the margins are such, or they have been in the past, that they will do that. They don't even, probably doesn't even know how much is coming out in the maize, or the barley, or whatever it may be. Now, what we're saying is, with the world running short, populations aren't running short, they're getting bigger. And what matters now is to put in place parsimonious systems. A system that, if you're going to export 5 kilograms, will accept 5 kilograms and not waste it, and will deliver that 5 kilograms into the crop. And I think the data, the data we have suggests that the Inga system is working in that way. So it's retrieving phosphorus that you add, it's retaining everything it found when it got planted, and it's recycling it. Because you're pruning, and it's got no choice. It's all coming back in the mulch. And at the same time, that mulch is a bit slow to decompose, which is a quality you want, and it's smothering the weeds. So the guys who would be putting in 60 to 100 man days a year slashing grass out of maize and beans are now saying, we didn't put any in. Not one day with a machete was needed to control weeds in this system. And not only that, they're getting firewood. And not only that, the system is on their doorstep, so that they're not having to walk miles. And what that means is the entire family, if they want to be, can be involved in their own economy. And that's a social transforming factor beyond just an easier way to grow crops. So, back to the 8-hectare model, or the Guama model, a hectare of alley cropping for basic grains will feed them. Another hectare of the same thing, but growing cash crops. Vanilla is a great one, but a bit risky, but pepper is one of the real goodies. You saw Faustino growing tomatoes. That's okay if you're not too far from somewhere to sell them. Pineapples would be the same thing. But examples of cash crops, okay? If they want perhaps a hectare of fruit trees, they can now do it because they don't have to slash and burn that site anymore. So they could put citrus or rambutan or passion fruit or something like that in the system. That will liberate 5 hectares of degraded land for trees, and they then can start sequestering carbon. So there's a complete rural livelihood there, and that's the model we're promoting in the Quero Valley, and that's also the one we're going to be rolling out as a sustainable rural livelihood for the whole region. We've got some funding now to. We couldn't mount the whole 10-year program in Quero, but 2 individuals. I don't know whether they want me to name them. They're private individuals who were taken by the film and got in touch. In fact, there are a number. There's a lady in Australia who had put a small amount of funding into Mapawi, and the director of Mapawi said, look, we're going to have to close this operation at the end of 2011. Can you we'll match your funding. So, if you can put in $16,000, we'll put in the 17, then we'll keep this thing going. And I wrote to her, email, and said, look, could your group in Australia, do you think, possibly raise the $16,000? And she immediately wrote a cheque for £16,000, and sent it, and just said, I'd like to help. And she's basically saved that entire project. Now, as things stand, that project is ticking, which is where we've been up to now with Faustino. He's on Sari, but we also now got a forester, a really gifted young guy, a great young guy. The team is just, the A team now is almost complete. There's one more guy to come in. So it's private individuals, but a couple of foundations have kept us going, and there's also the Vanderbilt Family Foundation put funds in to keep the demo farm running, and fantastic support from them. They're not huge quantities, but they keep us operating, they keep people employed, they keep the message slowly going out. When you say who's listening, it's more like who isn't.